You'd be surprised what comes up in conversation when paleontologists spend long days in the field. Some of it is deep time in ancient ecosystem. Some of it is, well, trying to remember our fourth favorite hat. This is Fourth Favorite Hat, a look into real dig site chatter of the Montana Dinosaur Center. Each episode brings you the work, the stories, the arguments, the questions, and the odd tangents that emerge when you put scientists, shovels, fossils, and too much sun in the same place. And yes, every guest still has to answer the only question that really matters. What's your fourth favorite hat? Let's get started.
Hello, my name is Andy, and my fourth favorite hat is my South Dakota Badlands dad cap.
I'm Brett, and my fourth favorite hat is my Lake Champlain Lake Monsters baseball cap.
I'm Bryce, and my fourth favorite hat is my wide-brimmed Denver Zoo hat.
Rounding out our talk about geologic time, we are going to wrap up with the current era of the Phanerozoic, the Cenozoic. This is going to cover a lot more of our recent stuff. This is going from about 66 million years ago to right now. This is commonly called the Age of the Mammals. There are a lot of mammal-dominated environments. There's a lot of mammal diversification going on. There's a lot going on with plant diversification. A lot of exciting things. All of this because it's picking up where the dinosaurs left off, basically. The non-avian dinosaurs and all sorts of other reptiles went extinct at the end of the Cretaceous, so now we have plenty of stuff to work with.
So we kind of get like a situation that's kind of similar to in the early Triassic, where there's just a bunch of open niches that evolutionary radiation happens, and then we get a whole bunch of weird guys kind of filling all the new roles.
The Cenozoic is divided into the Paleogene, the Neogene, and the Quaternary, and then if we divide those, the Paleogene has 3 epochs in it. The Paleocene, Eocene, and Oligocene. The Neogene has 2, the Miocene and the Pliocene. And the Quaternary has the Pleistocene and the Holocene. The reason why I, in particular, will talk about the Cenozoic epochs rather than, say, their period is because with the Cenozoic, we simply just have a lot more fossils available. This is from a phenomenon called the pull of the recent, where the younger something is, the less time it has to have been eroded away. So there was a previous idea that, say, mammoths were more abundant than even the most abundant dinosaur. That's not necessarily fair, because a lot of dinosaur fossils have just been eroded. There's millions of years of difference. But because of that, we have a very firm understanding of what has gone on in the various epochs of the Cenozoic. So let's start with the earliest one, the Paleocene. Paleocene starts the Paleogene. This is coming out right after the mass extinction event. And right away, there's some fun fellas coming out right off the bat. Mammals can now diversify. However, they are not necessarily the big dominant fellas just yet. Birds aren't done being dinosaurs, and terror birds evolve. And new studies have found more so that there's more herbivorous terror birds, but it's also still a large bird. Large birds like ostriches might not eat a lot of meat, but they still kick things to death. I don't think it makes it safe.
Yeah. But of course, we are still starting to get some larger mammals. During the Mesozoic, all the mammals that are around were, pretty small. And we're starting to actually get some ones that are like wolf-sized, even a little bigger during the Paleocene. Some actually large mammals, ones that would count as megafauna.
There's fella like Berry lambda, which is a type of mammal called a pantodont. Those are fully extinct now, but it got to about 650 kilograms. So a large creature.
Like cow-sized.
Yeah, there's some sizable ones. There's also plenty of small ones too. There are going to be relatives of possums that are about the same size, as it were. While mammals are going to diversify, there are plenty of mammals that just aren't going to make it later. So pantodonts don't really make it to the modern day. Do we get horses in the Paleocene, or is that the Eocene?
I think they show up in I was going to say, like,
I think it's their
the end of the
Eocene.
Eocene or the beginning of the Oligocene.
We're working with a lot of kind of ratty like fellas in between
Yeah, they come about during the Eocene, the first horses.
We're about to get there. The Paleocene is still a pretty dry and warm period. Average yearly temperatures are about 24 to 25 degrees Celsius compared to like our modern ones of where we're getting a yearly average of like 14 degrees Celsius. That's including like seasonality. Pretty warm. And It's not a extinction event, but more so a mass death event called the PETM, the Paleocene Eocene Thermal Maximum. And it's basically a massive fart. There's an instantaneous release of toxic methane gas that kills a large number of large-bodied mammals.
It's actually the most similar warming event that we see to current day.
This one doesn't really cause any of the species to go extinct, or I don't think it does.
Yeah, it does. I know there's like a good amount of extinction events actually.
I mean, multiple extinction events, but wasn't this more so just killing large-bodied individuals?
Like it caused mainly a lot of issues for like benthic foraminifera and various other small
Yeah, I
little
was gonna say
aquatic
like
guys.
oceanic stuff like
Yeah. So there's no extinctions terrestrially, but it does harm foraminifera, which are like shelled amoeba kind of dinoflagellates, lots of marine microscopic life. Some of those species go extinct, but we still have foraminifera today. So, but that's what starts the Eocene, the next part. This is where we get horses. They're very small. They've got multiple fingers. Horses evolve in a forest setting, so it doesn't make sense for them to be large and fast. It makes sense to be small and able to basically maneuver very well. But in the Eocene, we're going to see a lot of hoofed animals, our ungulates, start. We also see like the first bats or the first elephant relatives, as
the
well as
first whale like relatives as well.
whales have an interesting evolution. Why don't you tell us about it?
Oh, I know Bryce is a big fan of whales, so I might have to throw this one to Bryce actually. Bryce likes to follow.
That's fair. So whales are very interesting fellows because originally they were a terrestrial land-based mammal. One of those guys would be like Pakicetus, and they were kind of just going on. And then over time, they ended up getting minor aquatic adaptations to go towards like tide pools and more shallow water environments so they can try to get some more food sources. And then gradually, as time went on, they became less and less terrestrial, eventually becoming exclusively aquatic. Kind of like the exact reverse of like Tiktaalik back in the day, where things came onto land. They started on land and stopped.
Mhm.
Modern day whales do still actually have some vestigial hips. They're just kind of floating in there. They don't really do anything, but they're there.
There's evidence of their ancestral legs having a double pulley astragalus, which is very similar to modern even-toed ungulates. So stuff like cows, which blew our mind. It's like, wait, what? There's also a lot of what I call almost fellas. What I mean is Arsenotherium. It's almost a rhino. There's Hyenodon. It's almost a hyena. These fellas that kind of look similar to something but are not at all related. And then really cool guys called brontotheres. People mistake them for extinct rhinos. They are not really, not at all. There's just a lot of really cool mammals happening, but mammals are not the only things diversifying. They're just diversifying a lot. We still see bird diversification, stuff like carnivorous parrots, continuation of terror birds. You know, sharks are gonna keep diversifying. Sharks do well for a long time. Different turtles, different crocodiles, crabs. We're going to see some similar looking mollusk and crab fossils to what we have today.
Another thing that's diversifying pretty rapidly at this point is flowering plants and grasses as well. Not a lot of them going on during the Cretaceous period, but like now after the extinction event, they're really kind of taking over. And now flowering plants are becoming very common. Grasses are everywhere these days, but
Grass existed, but it wasn't widespread. You would find like
yeah,
small patches of it at best. It was
yeah, it first evolved during
Grasses
the
were
Cretaceous.
mainly in Asia at the time. They have found some like Hyosauroid specimens that had consumed grass before over in Asia at least.
I forget when the first fruit appears. Is that during the Eocene?
That's earlier. I think it's in the Cretaceous, isn't it?
I mean,
The first
to have
flowering plants.
to be a flowering plant doesn't
You have to
inherently
have
need the
fruit.
fruit.
Oh, okay,
Yeah.
well,
So,
I just know that like once we get
or
juicy
you talk about
fruits,
like more like colloquial fruit as opposed to
yes,
just fruit in general.
colloquially fruit. I think this is where we're seeing more like of that juice-bearing fruit kind of show in the fossil record, because we also see a lot of primate fossil teeth with cavities in them because of all the sugar from the fruits.
In general, we can tell a lot more about mammals based on teeth than a lot of these earlier animals because mammal teeth are so different. They can tell you a lot about how the animals lived and what they ate.
There are some mammals known purely off of teeth alone, and if I tried that with a dinosaur, I would say that's a crazy move. But for mammals, it makes enough sense. Then the final part of the Paleogene is the Oligocene. This is going to be 33.9 to about 23 million years ago. What's going on with the Oligocene? It's actually going to be getting cooler and drier, so this helps spread grasslands, which is going to play a big role in horse evolution. It gets warmer near the end, but it's overall a large cooling event. This is where we see the extinction of the multituberculates finally. Basically, before rodents, multituberculates were filling that role. They were doing that back in the dinosaur day, but rodents just finally outcompete them. We see a lot of mammals become cursorial, meaning adapted to running. So entelodonts, rhinos, camelids, those become runners. There were some pretty fast rhinos back in the day.
Yeah, we see like a lot of kind of weird animals kind of then. The biggest known mammals that have ever been found are from that time period, like the
Mhm.
Indricotheres.
Paraceratherium, that
Mhm.
fella. Big old
Yeah,
giraffe
basically
rhino kind of
imagine like a
fella.
giraffe rhino that's bigger than an elephant.
Yeah,
Kind of a weird thing, but they're huge.
and then like one of the contested heaviest mammalian predators is an entelodont called Daeodon. So these guys are like kind of look like murderous pig hippos, kind of related to both, but not too closely.
Very scary things though. If you know anything
Yes.
about, wild hogs or hippos, you can imagine a predatory one is very scary.
There is a fact I love to give people in that for a period of American history, pigs regularly ate camels because there was a small fella named Peobatherium, which was a very small but sprinting camel. And then these entelodonts, which are larger than me a lot of the times, would just eat them. You could kind of describe them as like a bear like animal via pig like evolution. I'm glad I didn't have to deal with that.
Yeah,
Yeah,
that would
no.
have made scavenging for food in the plains quite scary.
We see stuff like old world monkeys, as they're commonly called. There are oreodonts, which are best described as the most mammally looking mammal that ever mammaled. They got the specialized teeth, they got the hooves, they got it's a mammal. It's got the mammal things.
The first mastodons are also appearing.
Exciting stuff getting made possible because of these sort of coolings, as well as like changes in ocean circulation, all sorts of things. We get our first felid, so a little older than felids, where they're close relatives to mravids or the false cats. They're relatives of cats that look like cats, do the same thing as cats, but they're not cats. That's the easiest way to describe a nimravid, but eventually felids would outcompete them. Moving on to the Neogene, then we have the Miocene. This is before we hit like the what's commonly known as the ice ages, the glacial periods. There will be again general cooling. There's collisions of the Afro-Arabian plate with the Eurasian plate, allowing for dispersal of hominids and proboscideans into Eurasia. Keep an eye on this because that's going to matter for human sake. But this is kind of the epoch where human ancestors are kind of finally considered split. The hominids, grasslands that were starting to form in the Oligocene have spread even more as the kind of global trend of forests and jungles become less prominent.
But at this point, if you were kind of sent back there, if you saw like the environments, they might look honestly pretty similar to today in terms of like the plants that are living there.
Mm,
Mhm.
Maybe not the animals as much.
There's
maybe
some
not.
there's some
But some of the
similar looking
animals,
fellas though.
some of the animals are, still around today, but some of them are not.
Mhm.
We're starting to get to the time period though where it's some overlap now with today.
Yeah. We start to see a lot of evolution causing the high crowned grazers due to the very firm, fire resistant nature of like these grasses full of stuff called phytolith, microquartz kind of crystals that give grass structure, really breaks down teeth quickly. So there's a couple evolutionary things that are tried. One is just to have bigger crowns to your teeth like a horse does, and now you have more to wear down. Another attempt was just develop a really, really thick layer of enamel. We don't really see too many mammals like that survive, or, well, the lineage go further. And then another one, I forget who does it, but they make like a cheese grater out of enamel for their teeth. It's really weird. Doesn't really go anywhere. Yeah. But tougher plant material causes a need for tooth evolution to kind of. It's that evolutionary arms race just between herbivores and plants. Besides that, we are seeing the diversification of hominids. We are seeing a sad decline of corals due to warming of seawaters. The Miocene has the greatest amount of whale diversity that has ever been, with about 20 recognized genera of whales, baleen whales. This is also when we get Megalodon, a very famous shark. Bryce, could you tell us a bit about Megalodon?
Megalodon is pretty much the largest shark that we currently know of, and is very famous for a lot of more recent conspiracy theories regarding late surviving megafauna. People like to say that it lives in like deep parts of the ocean or like the Marianas Trench or any unexplored portion of the ocean.
And
But
does it?
seemingly not, no.
No, a big issue with that is that this was a whale eating animal. It needs to eat whales. So there's not a lot of whales in the Mariana Trench.
No. Not very much. Not very many.
It wouldn't do too well down there.
No, it super wouldn't. We also get a massive caiman called Purosaurus, or Purosaurus in South America. So crocodilians, still horrific, still big old predators. After the Miocene is the Pliocene.
Once we get to the Pliocene, it's going to be honestly pretty similar to today in terms of most of the life. Of course, there are many differences, but generally about probably 90% is stuff that's going to be closely related to things that are still around today.
Yeah, so like a good example is not everything survives because things are cooling, it's moving towards the ice ages. Europe now no longer has venomous snakes or alligators or crocodiles. But like the species of crocodile that we see, or the species of alligator, Alligator mississippiensis, that one already evolved last epoch. It's doing fine in America.
There's some that are going to be, not around anymore. Like, of course, like mammoths and mastodons aren't going to be around anymore, but, they're close cousins, the elephants still are. Generally, things have some ancestors still around today.
It's not like we're losing huge groups of mammals at the moment. It's not like when we lost the pantodons or the psittacotheriums. Those don't have any descendants. Most of these things, like Glyptodon, that's got armadillos or its descendants, or its relatives at the very least. Giant ground sloths have, well, the tree sloths as their relatives.
So pretty much for this time period, you can think back to like the ice ages. Those are the types of animals that are around at that period. So a lot of stuff that's still around today, but also, mammoths, mastodons, saber-toothed tigers, dire wolves, things like that. This kind of is through this whole time period. Cave bears.
We also start to see occurrence of like hunting and various other more human like artifacts and evidence in the fossil record as well. Well, not humans,
not
but
quite human ancestors.
Once we hit the next stage, the Pleistocene, we're getting Homo habilis, Homo ergaster, Homo erectus, Homo heidelbergensis, Neanderthalensis, and then the last to kind of hit the scene is Homo sapien, which is us. So spoiler alert, we didn't go extinct like the other ones.
seemingly not yet.
Also, a lot of the proboscideans are doing well. We still have a pretty diverse group of them. We still have the gomphotheres, which are kind of like the weird fellas, the mammoths, the mastodons, all sorts of groups.
By the weird fellas, he means that they have like the shovel tusks, typically, the gomphotheres, where they'll have an extra set of tusks.
Once we get to the Pleistocene, we see a lot of human interaction, humans even interacting with different species of humans. There's even plenty of evidence for interbreeding, which kind of brings into questions of, are we talking then just about subspecies? I don't know. Bryce, you're the biologist. What's your opinions on that?
On interbreeding between humans and human ancestors or relatives?
Yeah, like, do you think it's Homo neanderthalensis or Homo sapiens neanderthalensis? Is it a subspecies, or what are your opinions?
Truth be told, I haven't really looked too much into the actual evolution of humans per se, but there are different groups of people from across the earth have different percentages of Neanderthal DNA within them. People who are from like Asia and Europe tend to have a higher concentration of Neanderthal DNA than those who are from Africa.
Yeah. Now, Bryce, I spat in an envelope and sent it off to one of those DNA test sites, and they said that I'm 102% Neanderthal. What does that mean?
Oh, well, they come with a bit of a margin of error. So since you got 102%, I'm assuming it's a 2% margin of error. So you are actually 100% Neanderthal. So congratulations.
Oh, this is just like the Michael Crichton book, Eaters of the Dead, with the last remaining Neanderthals.
It's a good book.
It's a fun one. Well, I don't know if fun's the right word.
It's not just Neanderthals that are interbreeding with modern humans as well. There's other ones like the Denisovans. It's not just Neanderthals.
Humans also come to North America via the land bridge Beringia from Asia.
And they're not the only things. Lots of animals are going through this big interchange between North America and Asia.
We also have several glacial cycles of this. This is what we're going to be calling the Ice Age.
The Ice Ages.
So Ice Age geologically just means any period of time with ice caps. But from a colloquial sense, these glacial periods are the ice ages. We got stuff like woolly mammoths and our reindeers and our woolly rhinos and our cave lions, those kind of fellas.
The Ice Ages are still technically going on today, but normally when people talk about the Ice Age, they're talking about the last glacial maximum, which was basically the end of the Pleistocene. That's when we see the retreat of the ice sheets that used to cover pretty much the northern half of North America and Europe and Asia. That basically they retreat and there's a big die-off event of megafauna, things like Andy just talked about. And that's kind of what leads us to our kind of last little era,
Yeah.
the Holocene, which is where we are today.
So the Holocene is described as the epoch of human interaction. This is where it's just Homo sapiens, and this is including all of our history right since the last glacial period. So, a lot of things happen in that time period. There's some rough divisions, the Mesolithic, Neolithic, then the Bronze Age, like based off of how many tools we use. It's also a time period of constant climatic flux. There's a lot of change. There's a lot of changes in ocean chemistry, and a lot of that is going to be coming more recently. We have a large impact on what's happening in the Holocene.
Yeah, some people have actually said that we should put up a new geologic era called the Anthropocene, started, sometime since I think 1900 was the cutoff, because the amount of change to the Earth's biosphere by humans is so evident now, be so evident in the geologic record that it should be called a different thing because of things like plastic everywhere, things like that, where it's just such a marked difference and the impact we're having not only on the planet geologically, but also on the species that are in the extinction event.
There's a lot of arguing dates proposed. Some people want it to be when the first nuclear bomb was tested because new elements were introduced into the atmosphere. Some people want it to be at the invention of plastics or the start of the Industrial Revolution. So this is sort of why Anthropocene has not been accepted, as well as I'm of the opinion it should be an age of the Holocene, like the Greenlandian, the North Grippian, or the Meghalayan, so maybe call it the Anthropian. That's just my opinion. But it's a ongoing scientific debate, and part of that is we encourage everyone to share their voice on it, to read up and see what they think.
I think in general, people should be aware of the effects that humans are having. And we've talked about there being 5 big extinction events, but there's actually an argument that we're going through a 6th great extinction event now that is human caused. Already, lots of species of insects and things like that have already gone extinct, and many more are becoming endangered, and that amount increases every year.
Yes.
So we're definitely getting to the point where we're getting close to being a mass extinction event. So it's something people should be aware of.
Yeah, and it is up to us to prevent that. And as scary as it may sound, there is still hope. We have a lot of ability to fix things. We do see things improve, but we have to put the effort into it to save our environment. And hopefully that message of hope kind of inspires you guys to, humans can influence our environment and we can influence it for the better. So as always, I've been Andy.
I'm Brett.
I will be Bryce.
And have a good one.
That's one conversation down, and there's millions more waiting for us out in the ancient dirt. If you want to join the crew on their next auditory adventure, subscribe to the Fourth Favorite Hat, the Montana Dinosaur Center podcast, available wherever podcasts are distributed. You can follow the museum on social media at TM Dinosaur Center, visit tmdinosaurcenter.org, or swing by the museum in Bynum, about 80 minutes north of Great Falls on Highway 89. Thanks for listening.